In the context of combined experimental research for on-surface chemistry, we demonstrate how an electronic lab notebook used to document experimental steps can interoperate with a workflow management system used to track the provenance of simulations. It starts by showing the steps of a microscopy experiment, which are already present in the ELN. Then, from the experiment, a WFMS is accessed to run STM simulations. Afterwards, the results are inspected and sent back to the ELN. Finally, the simulation data sent to the ELN are verified to check whether they are in the correct context. In this demo, we showed interoperability between a workflow manager system and an electronic lab notebook in the case of a combined experimental computational research work for the microscopy of adsorbents on a substrate. The case we show comprises storing and creating relations between data from simulations and data from experiments. The ELN that we are using is openbis. In openbis, there is a lab notebook section to store data regarding the experiments, inventories to store so-called objects like molecules we have maintained in our demo, or atomistic models, which is currently empty because we did not run any simulation yet. You can also save instruments, people, institutions, among others. The simplified experiment that we already stored in openbis for this video starts with a sputtering procedure needed to clean the surface of a crystal, gold in this case. The object contains not only a connection to the crystal and an instrument, but also some parameters such as duration and pressure. After sputtering, the sample is annealed. The annealing object is connected to the sputtering object, and it also contains some settings within it. Then the deposition procedure is performed. It means that a molecule methane, in this case, is deposited on the crystal. Connection to the molecule and to the annealing objects are created. The deposition object contains details such as deposition time and pressure, among others. The sample is afterwards annealed again, and additional steps may occur. All objects are defined according to the metadata schema developed within PREMISE. When the sample is ready for measurements, we can record different microscopy images, for example, through AFM or STM experiments. As soon as the raw data are transferred from the microscopy instrument to the ELN, the plugin developed in the PREMISE project extracts the pertinent metadata and creates image galleries. The user can access the microscopy metadata and change image settings using the buttons inside this plugin. If we now want to obtain a simulation pertinent to this specific experiment, we can simply click on the experiment and select a workflow manager, that is AiiDAlab in this example. AiiDAlab will receive the molecule used, that is the methane in this case, and the identifier of the experiment. Then we can start a geometry optimization. We just have to edit the sample by adding a subset. That is gold 1 in this case. Let's add a small one. So we adjust the parameters. We add the slab. We store in AiiDA. Then we select the simulation accuracy. We select the simulation code. We select the computational resources, and we give a title to the simulation. When the simulation is completed, we can search for the automatically retrieved results. We just have to open the search page, search within a certain data range. And now let's select one simulation that was already done, because this takes some time. The user can access the optimized geometry and export it to the ELN together with the whole simulation provenance. Now, let's perform the STM simulation. We have to open the Scanning Pro Microscopy page. We have to select the structure. Let's select this one. We have to select the simulation accuracy. We have to select the FTM time, that is FTM in this case, the different parameters, the codes, and the resources, and finally, a title. And we submit it. Again, let's go back to the search to open an STM that was already performed. Let's search it. And now let's open this one. Here, you can see that the simulated images are already done. You can check them here. And afterwards, all this information can be exported to the ELN. just by clicking on Send to ELN button. And it sends all the information back to openbis. As you can see here, the objects are created, the relations are also created here, the data sets are uploaded. And then let's go back to the ELN UI. And you can see that inside the experiment methane on gold, there is now the simulation regarding the geometry optimization and the simulation regarding the FDM. And also the atomistic models are stored.